Hey everybody, in this video we are going to evaluate more trig expressions using identities. We write the following expressions using the sum or difference formulas or double angle formulas. So we basically have angles inside the parentheses here, okay, inside of our functions that are not on the unit circle. We can't evaluate them the way they are. We're going to be able to rewrite it and then evaluate it, likely. Probably, we'll see. So that's what we're going to do right now. So first thing I notice is that there is a 6 in front of both things, right? I'm going to take this 6 and I'm going to factor the 6 all the way out front for number 28. So 6 parenthesis, and then I'm going to call alpha pi over 5. I'm going to call beta 2 pi over 7. And I'm going to kind of rewrite, okay? Cosine alpha, cosine beta plus, the 6 is out, sine alpha, sine beta, right? That helps me see a little bit better. So when you have cosine, cosine minus sine, sine, that is the cosine angle sum identity because cosine is the opposite sign. 6 times, it's a cosine identity. I'm reworking identity. It's not like the signs are disappearing. This is the right-hand side of the identity that we're looking at. The left-hand side would be alpha minus beta like that, and that 6 is being multiplied out front. Sorry, the C is so ugly. So we have 6 times cosine, I'm going to fill them in now, pi over 5 minus 2 pi over 7. Com denom will be 35. This gets multiplied by 7 on top and bottom, by 5 on top and bottom. If you write times 5 and times 7 as if you're only multiplying on top, I will take points off because that's wrong. It's 7 over 7 or it's 5 over 5. If you're multiplying by 7, only the top gets a 7. I don't care how big you make the 7. If it's as big as the whole fraction, it's wrong. Okay? Let's grow up a little bit with the notation, shall we? So that means you have 6 cosine of 7 pi over 35 minus 10 pi over 35, which is 6 times the cosine of negative 3 pi over 35. So this one got us all the way down to here. Is this on the unit circle? Nope. That means that's as far as we can take this example. Maybe one step further. If you know the opposite angle identities, you know that cosine is even. The cosine of a negative angle will equal the cosine of a positive angle. So you can just continue cosine of 3 pi over 35. That negative could go away. The 6 and the 35 and the 3 have nothing to do with, the 6. The 6 is out front. It can't be multiplied by the cosine of 3 pi over 30. It can't be multiplied by 3 pi over 35. So we just done. That's it. You're done. Okay? Next. If we look, we have 2, 4 pi over 3, 4 pi over 3, 2 sine theta cosine theta. Do you see that happening right there? Yeah? So that is double angle identity. What does that equal? That equals the sine of 2 theta. And I have a negative and a 1. Okay? One thing at a time. Negative 1 I could leave on top. I'm going to do that. Sine of 2 times 4 pi over 3, like that. 2 theta. Theta was 4 pi over 3. Negative 1 over sine of 8 pi over 3. But 1 over sine is the same as cosecant, so negative cosecant of 8 pi over 3. This one, unlike the one before it, can be evaluated, and I think we should evaluate it. 8 pi over 3, so I'm skinny like a tree. There's 6 pi over 3, 7 pi over 3, 8 pi over 3 is here. Sine is up a lot, root 3 over 2. So that means cosecant is 2 root 3 over 3, but the negative sitting out front, that just comes along for the ride. Negative 2 root 3 over 3, and that's it. We're done. So unlike number 28, which we couldn't have evaluated because we got stuck, number 29 we could, because it was a special angle. I had a 3, 4, 6, 2 as the denominator. You know what I'm saying? So that's number 29. And last but not least, we have this one here, 30. So I have basically alpha is 7 pi over 9 when beta is 6 pi over 5. So what am I looking at? I'm looking at tan alpha plus tan beta all over 1 minus tan alpha tan beta. That is the tangent angle sum identity, tan of alpha plus beta. That's the formula. That formula goes with this, that these are equal. So I'm going to go to here. I'm going to plug back in. Tan of 7 pi over 9 plus 6 pi over 5. Keep going. Don't stop there. No one said you're done. We didn't say you could stop. I'm going to add. I need a common denom. That's going to be 45. So this is going to get multiplied by 5 on top and bottom by 9 on top and bottom. Tan of 35 pi over 45 plus 54 pi over 45. Tan of 30 and 50 is 80, 89 pi over 45, and that does not reduce, so I'm stuck. Done. 81 divides by 9. 90 divides by 9, but 89 does not. And 45 divides by 9 and 5 and 3. But if 9 doesn't go in, obviously 5 doesn't go in. So that's it. That's as far as we can go for this example. Hopefully I didn't mess up writing any of the numbers down. I hope I copied everything down correctly. It looks like I did. Be careful with tangent, because when it's upside down, it's technically cotangent, and I feel like it's very easy to misread the tangent. So, you know, take it easy with that. But that's the end of this little set right here. Hopefully that was helpful. Thumbs up to say thanks. Thumbs down to tell me no thanks. Questions, comments, concerns, requests in the comment section, please. Check the playlist for more of what you need. Good luck. Bye.